Hi, this is Algebra 1, Lesson 81. We're going to talk about complex numbers and real numbers and products of complex conjugates and the division of complex numbers. We're starting on page 335. A complex number has a real part and an imaginary part. When the real part is written first, we say that it's in standard form. So we're starting with a little bit of math theory here. Here's the standard form a, which is some number, plus bi. So this is I, or the square root of -1, times a coefficient. So here are some examples of complex numbers written in standard form. -2 plus 3i. 4 times the square root of 3 over 5 plus 2i times the square root of 3. 3 minus 23i times the square root of 2 over 2. These are all complex numbers written in standard form because all of the replacements for a and for b are real numbers. If a equals 0, then the number doesn't have a written real part anymore. So these, 3i and 2i times the square root of 3 and -23i times the square root of 2 over 2 are complex numbers whose real parts equal 0. If the coefficient of the imaginary part of a complex fraction equals 0, we get a complex number with no written imaginary parts. So, -2 plus 0i. -4 times the square root of 3 over 5, or 3. So every real number can be considered a complex number whose imaginary part equals 0. And every imaginary number can be considered a complex number whose real part equals 0. So we can say that real numbers are a subset of complex numbers and imaginary numbers are a subset of complex numbers. Okay? This complex number is not in standard form. Okay? If we divide 5 by both terms in the numerator, we will get 4/5 minus 3i fifths. Or you can say 3/5 I. They would probably like that better. 3/5 I. Okay, now we're written in standard form. You're going to need that. Okay, that's enough math theory for the moment. Let's get to a place where we can do things with them. So before we've talked about the products of conjugates, and when you multiply conjugates, you get the difference of two squares, right? This time we're going to do complex conjugates. That means that there's going to be an imaginary number. Okay, so let's start with just multiplying conjugates together. So a plus b times a minus b, we get -b squared minus ab plus ab and a squared. So we've got a squared, these cancel, minus b squared. Alright, we have the difference of two squares. If we do that with square roots, this is going to make -25 times 2 minus 15 times the square root of 2 plus 15 times the square root of 2 and 9. Okay, this equals 9 minus 25 times 2, which equals 9 minus 50, which equals 41. Okay, so when we multiply just regular conjugates in two terms together, we got the difference of two squares. When we multiply the conjugates of complex numbers, we're going to get the sum of two squares. So let's try that. Here we have negative b squared I squared minus abi. Here we have positive abi and a squared, right? This cancels, and we've got a squared minus b squared I squared. Now when we simplify this, we know that I squared equals -1, right? Because I is the square root of -1. So this is going to be the same as I squared minus b squared times -1, which equals a squared plus b squared, the sum of two squares. Okay, let's try this one. We have -16I squared, -12I. Here we have positive 12I and 9. Okay, these cancel, and we have 9 minus 16I squared, which is the same as 9 minus 16 times -1, which is the same as 9 plus 16, which equals 25. Okay, you notice that once you multiply these through, neither of these products has an imaginary part anymore. We can use this to eliminate the I factor from the denominator of a complex fraction. Okay, so let's talk about the division of complex numbers. You remember when we are dividing polynomials, we do it like this. We have x plus 3 x squared minus 2x plus 7. And we work with the x. So the x is going to go into x squared minus 2x, x times. We multiply that through and we get x squared plus 3x. And we're going to subtract this, which means this actually turns into a negative. So this is minus 5x plus 7. And x goes into this minus 5 times. So this will be minus 5x minus 15. But then we're taking the negative of both of those. So those all turn into positives. So this cancels, and we have 22. So our answer here is x minus 5 plus 22 over x plus 3, right? And that is your final crazy answer. We can't do long division like this with complex numbers, thank goodness. So, if we see something like this, we're going to simplify it by multiplying by the conjugate of the denominator. So we're going to get rid of the I in the denominator. So we're going to multiply top and bottom times the denominator times the conjugate like this. Okay? And now we have to multiply these. So we have 2 plus 3i times 4 plus 2i over 4 minus 2i times 4 plus 2i. Right, let's use FOIL here. We have 8 plus 4i plus 12i plus 6i squared over, here's 16 plus 8i minus 8i minus 4i squared. Okay, these cancel. These are actually negative ones, right? Now we can simplify this mess. So we have 8 plus 16i minus 6 over 16 plus 4. Notice all the i's in the bottom have disappeared. So over here we have 2 plus 16i over 20. Okay, we need to put this back into standard form. So we have, and we can divide this out a bit. Well, we'll have 2 over 20 plus 16 over 20 times I, and that's going to equal 1/10 plus 8. Nope, we can divide both of those by 4. So we'll have 4/5 I. And that will be your answer. Okay, let's try another example. Simplify 4 minus 2i over 2i minus 3. So we're going to multiply the top and bottom times the conjugate of the denominator to get rid of the i's in the denominator. Okay, so we have 4 minus 2i times 2i plus 3 over your book probably turned this around. It's going to come out with the same answer. It's just not really in standard form. 2i plus 3. Okay, this is going to be 8i plus 12 minus 4i squared minus 6i all over 4i squared plus 6i minus 6i minus 9. Okay, to simplify this mess, this is -1, this is -1, these two cancel, right? So we have, let's put the like terms together, we have 8i minus 6i, which is 2i. We have 12 -4 times -1 equals 4. So this is 12 plus 4. This is 16 over. And here we have -1 plus -9, which is -10. Okay, we're going to simplify this and put it into standard form. So we'll have -16/10, right, minus 2 over 10i. We can simplify this mess by saying -8/5 minus 1/5 I. And that is not correct. What did I do wrong? Oh, I lost a 4. Ha! Alright. Never mind all this. I lost a 4 here. So we've got... Alright, so our top was still correct. We had 2i, and 12 plus 4 is 16. And in the bottom, this is -4 times 4. So we have -4 minus 9. Sorry about that. So let's put this kind of in standard form. We have 16 plus 2i over -13. Okay, and now we're going to write this in standard form. So we have -16 over 13 minus 2 over 13i. And that would be your correct answer. Okay, that messiness is it for this lesson. Try the practice problems. Let me know if you have any questions, and do your homework. Thank you very much.